Sabrina. I'm a rising junior at Castellet School. And for my starter project, I actually made 2 starter projects because my first one wasn't really working. So the first one that I did was an ultrasonic parking sensor, and the way it works is you have 2 sensors right here, and then one will emit a sound wave, and then it'll bounce off an object on the street, like a car or a curb or whatever you're trying to park next to but you don't want to hit. And then it'll actually bounce back, and the other sensor will receive it, and that's actually converted into a frequency and a voltage. And then there's a diode here in this circuit right here, and it actually, current can't go through a diode unless it reaches the breakdown threshold, and it'll only reach the breakdown threshold if the object that you're not trying to hit is within a certain distance from the sensor. So if it does reach the breakdown threshold, then the current can go through and it'll trigger this buzzer, and then this buzzer is there to alert you that you're too close to whatever you're about to hit, like a car or a curb or something. Unfortunately, for whatever reason, mine wasn't working because there were 3 other people actually in this program who were doing the same project. So when mine wasn't working, I compared it to different people's projects, and I looked to see if everyone was there. Everything on my circuit board was there, if there was anything backwards or anything wrong, and I checked if I short-circuited or anything, and I couldn't figure out what the problem was, so we just concluded that there was a defective part for some reason. So I just decided to scrap that project, and I made another one. It was a lot simpler just because I wanted to get started on my main project soon. And the way this works is that you can just shine a laser onto the circuit, and then it'll light up LEDs. And the way that works is that this little orange thing in the middle right here is called a CDS, and it has very high resistance, but the resistance decreases as the light intensity shined on it increases. So if you use a laser or something with a very high light intensity, then the resistance will go down enough that current can actually flow through the system, and it can actually light up LEDs. So that was my second one, and luckily that one worked. So then I was going to start my main project. And this is my main project. It's a solar panel sun tracker. And there are kind of 2 main mechanisms to my project. The first one allows the solar panel to follow the sun each day. And then the second one allows the sun to adjust to the different angles of the sun rays, because the angles of the sun rays change seasonally. So for my first project, or for my first main mechanism, here I'll just power it up right here and show you. I'm using my computer because I'm going to change the code in the middle of the presentation. So this is kind of the way it works. It can rotate, and I'll just unplug it to explain it. So the way it works is at midnight, it only does 1 full rotation every 24 hours. So at midnight, the solar panel will start face down, and then as the sun rises, like if my fist is the sun, as the sun rises, the solar panel will be able to follow the sun. So when the sun is at its peak, the solar panel will be completely faced up, and then as the sun sets, the solar panel will continue to following it, and then at midnight, it'll be completely ready to make another full rotation each day. So that was my first one. And the way I did it was this motor right here is connected to a gear. So the motor powers the gear and makes that spin. And then it meshes with this gear right here, so it makes that one spin. And because this gear is connected to the shaft, it makes the whole shaft spin. And because the solar panel is on the shaft, it makes the solar panel spin. And then I used an Arduino actually because the motors that we had available do 30 rotations a minute, and I wanted to do 1 rotation in 24 hours. So I thought, well, maybe I can use gear ratios to slow down the solar panel, but unfortunately, when I calculated the gear ratio, it ended up being 1 to 43,000. So I realized that probably wasn't going to be doable. So instead I used an Arduino, which would slow it down, and I used something called a PWM, which stands for Pulse Width Modulation. And basically what it does is it kind of it gives off the effect that it's slowing down a motor, because it'll turn on the motor off and on really, really fast so that it looks like it's continuously rotating, but it looks like it's rotating slower, but it's actually rotating at the same speed, but it's turning off so fast, turning on and off so fast that it just makes it look slower. And then you can actually change the speed and make it even slower by just increasing the ratio of the time or the percentage that it's off and to the percentage that it's on per rotation. So that'll make it go slower. So for example, just unlock my computer. So currently it's going at its normal speed, but if I want to make it go like half as fast, let's say, I upload the code. So now it's moving a lot slower. So the motor, or it looks like it's moving a lot slower, but the motor is actually moving at the same speed, but it's off more than it's on than it was previously, so it gives off the effect that it's moving slower. So that's kind of how the solar panel follows the sun daily. And then I'm not going to show you how slow it actually is supposed to move because it does one rotation in 24 hours, so we would be sitting here for 24 hours if we wanted to see it with the full rotation. So I won't bore you guys with that. But then for my second mechanism, because the sun actually changes, the rays hit the earth at a different angle for a different season. So for example, I'm going to unplug this. So for example, in June, the sun rays hit roughly at 180 degrees, so they hit kind of straight down. But then as different months go by, for example, the winter, the angle at which, the angle from the sun rays to the ground is actually very, very tiny, so the sun rays are hitting almost like this. But you want to make sure that the solar panel and the sun rays are hitting at exactly a 90-degree angle to ensure that your solar panel is getting the maximum amount of energy possible from the sun. So I built a sliding mechanism so the solar panel can change angles. So in June it's completely flat because the sun rays are hitting 180 degrees. However, between June and December, you're going to increase your angle of the solar panel so that, like, in July, in July, the solar panel is going to be at a higher angle so that it can still hit perpendicular. So for example, in December, because your angle is most severe in December, your solar panel actually is going to be hitting at this angle, and then that is going to ensure that it's hitting completely at a 90-degree angle. And the way I built this is that I just kind of used magnets. So I'm going to detach this actually, just to show you. So the magnets are actually glued onto this wooden frame right here on the inside, and there are magnets here too, as you can see. So then these just snap on, and then it can just move up and down. And one thing that I had to think about was I realized that the solar panel is not going to move up and down in a completely linear way. So this metal rod can actually be stationary because the way that this is going to move, it actually moves in like an arc shape. So I had to make sure that this was it had the flexibility to move so that to enable this to move in an arc shape because I didn't have like an arc rod. So I just used a door hinge instead of making it stationary with like an L bracket or something. So that allowed this to move. And then I used hinges here because I needed to make sure that it could stay connected to the base, but it could still kind of move and tilt. So I just connected two pieces of wood with a door hinge, and one stays connected to the base, and the other one just stays and can rotate back and forth. So yeah, that's my solar panel.
Does it rotate on a program to rotate with the month?
Oh, yeah, that's actually one of the things I'm thinking about as a modification. So I actually forgot to mention that, thank you. So I currently don't actually have a way to motorize this right now. Right now it just moves with the months, but it's not as big a deal as this because I would have to constantly be sitting there rotating this. But with this, I only have to move it once a month because the angles only change once a month. But I'm currently thinking about a way that I could actually motorize it. And I also want to change that because, as you can see, it's already getting really scratched up. So I'm not sure if the sliding mechanism could be like a permanent fix. So I'm thinking of a better way to actually do the sliding mechanism and have it motorized at the same time.
Do you know what like the ratio of energy you're using to rotate the solar panel is to the energy you're producing with the solar panel?
Yeah. I'm actually using different batteries for what the energy that I'm harnessing and the battery that I will use to motorize the gear. I think that I'm using, I'm not actually sure what the ratio is. I'll look into that, but I definitely know that for sure that I'm harnessing more energy than I'm using to motorize this. But yeah, I'm not totally sure what the ratio is. Yeah.
Do you have a way to adjust to the length of day?
You mean like, oh yeah. So I was thinking of just kind of slowing this down or speeding it up based on the length of day. So like, obviously if the sun sets faster in the winter, or like, you know, the time that the sun's up in the winter, so then I'll just speed this up a little bit and I can use angles to make sure that it's at a 90-degree angle. Do you want to?
So Arduino is consists of a lot of projects. What is this Arduino thing?
It's a microcontroller, so it's a great way. I forget what it's called, but it's a way that you can actually upload your code and everyone can see it and everyone can edit it together and like make modifications to it. So it's kind of like a database for engineers. That's how I think of it, kind of. I forget what you call that though. What is it called?
Open source.
Yeah, open source. So yeah, it's pretty cool. And Arduino deals a lot with like sensors and a lot of stuff like that. I didn't use Arduino a lot, but I'm sure a lot of other, because I know like a lot of other projects, like the bouncing robot, is a lot with Arduino. So I'm sure they can talk a lot about that. Yeah, I wish I got to use it more, but yeah, pretty cool.
Thank you.
Next will be Tommy.